So like I was saying earlier, when we study average rates of change, it leads right into derivatives. With derivatives, we're finding instantaneous rates of change. Average rates of change just means that we're looking at two values, and we're looking for the average for that rate of change. Calculus is more powerful. With calculus, we can find the rate of change at one specific x, or at one specific time. But we encounter average rates of change in a lot of different forms. We can find average speed, which is going to be measured in miles per hour, or it could be kilometers per second, or feet per minute. All kinds of different units that we could use. In growth rates of populations, a lot of times we can look at like the growth rate in a city. Like for Cincinnati, sometimes we have an increase, sometimes there's a decrease, and that's just looking at the average there. And also the average monthly rainfall. We can look at it in inches per month. The average rate of change of a quantity over a period of time is the amount of change divided by the time it takes for that change to occur. In general, the average rate of change of a function over an interval is the amount of change divided by the length of the interval. Now, the length of the interval can be measured in terms of x or in terms of time. We'll be looking at both cases. So to find the average rate of change given f of x and given a closed interval from x sub 1 to x sub 2, here's what we have to do. We have to find the y values at x sub 1 and x sub 2. Remember, these might be representing x values, but they also may be representing times. But either way, we have to plug in those x values into the function to find the corresponding y values. We have to find that change there by subtracting, and then we have to find the difference between the x's, or the difference between the times. This is the same method as finding the slope of the line connecting 2 points, the same exact thing. So we're going to look at the average rate of change. Here's our function. What kind of shape is this, by the way? Parabola shifted up 4 units. Over the interval from x equals 1 to x equals 4, we're trying to find this average rate of change. We will abbreviate this as AROC, just the first letters in each of those words, average rate of change. So we're going to find that for this problem. So to find the average rate of change, the first thing I have to do is I have to know what is f of 1. So if we plug 1 into this function, what do we get? 5. Then I also have to know what is f of 4. If we plug in 4, what are we going to get? 20. So these are our y values. So now if I want to find that average rate of change, the first thing I have to do is find the y values. Now I have to find the slope. Slope is the same thing as average rate of change. So I'm going to do y sub 2 minus y sub 1 over x sub 2. See, this is x sub 1, this is x sub 2. So x sub 2 minus x sub 1. So I'm going to get 15 over 3, which is 5. So that's the average rate of change there. Let me show you this from a visual point of view. Here's what we're doing. I also could have done this on the calculator. I have x squared plus 4. If I just look at that, I'm looking at this between x equals 1 and x equals 4. X equals 4 is really high up there. So I might want to make this go a little higher. Here's the picture. So from right here to x equals 4 right here, I'm basically finding the rate of change there, the average rate of change between those 2 points. I also could have used my calculator to find those values. Right here's f of 1 if I want to double check, and right here's f of 4 if I wanted to check that. All right, let's look at number 2. So on day 10, there are 200 bacteria in a petri dish. On day 15, there are 522 bacteria. So here's the way I would write this. Day 10, 200. Day 15 has 522. The only difference between this one and the number 2 is that now we're comparing time and bacteria. Time and bacteria. So if I want to find the average rate of change, And I can think of this as the change in bacteria over the change in time. That's what I'm really trying to find. What's delta always means change, so the change in the bacteria over the change in the time. So I'm going to look at the change in the bacteria, 522 minus 200, the change in the time, 15 minus 10, and we're going to get 322 divided by 5. I should probably change that into a mixed number. So what I do is 32 divided by 5 would be 6 with 2 left over. 5 goes into 22 4 times with 2 left over. So I'm going to get 64.4 bacteria per day. So on average, that's how much the change is for the bacteria compared to the day. All right, for number 3, we're asked to find, here's our function, f of x equals 2 plus cosine x over this interval from 0 to pi. In this case, this is x sub 1, this is x sub 2. So here's what we're really looking at. If I wanted to graph this on the calculator, I could go to y equals, do a zoom trig, and here's the way the function looks. It's a cosine curve shifted up 2 units. I'm trying to find from 0 to pi. Here would be 0, here would be pi. What's that rate of change? First of all, what do I definitely know about that rate of change from 0 to pi? It's negative, yeah. I can see that it should be negative. So now I have to find my points. So if I plug in 0, what's the cosine of 0? 1 plus 2 is 3. If we plug in pi, what's the cosine of pi? Plus 2 is 1. Okay, so we're just finding those points. Remember, I could also find those points on the calculator. But look, if I go to my table, that's not really what I want to see. So what I could do is I could set up my table to start at 0 and go up by pi. If I just want to see those points and I want to check them. So I can now see that when x is 0, here's my answer, and when x is pi, here's my answer. Just some quick ways I can do that. Another way I can do that, if I don't want to go to my table, take this back to normal, but if I go to my graph and I just do trace and I put in pi, it'll tell me the answer. When x is pi, there's my y value. So lots of different ways we can check it. I can also do trace and I can put in 0. And when x is 0, y is 3. So now I want to find my average rate of change. So I can just do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's going to give me negative 2 over pi. That's the exact rate of change. If I wanted an approximate value, I could go to my calculator and I could do negative 2 divided by pi. So it's approximately negative 0.637. And that change would be representing the change in f of x compared to the change in x. So it's the change in y over the change in x. That's what that is. Questions there? All right. Next one, find the equation of the line through these 2 points. We have 2 ways of doing that. One way is to use y equals mx plus b, substitute in for x and y and plug in for m, solve for b. The other way to do it is y minus y sub 1 equals m times x minus x sub 1. Sub in for y, sub in for m, sub in for x sub 1. Do most of you use number 1 or the number 2 method? Okay, I see a lot of people saying number 2. Okay, so I'll go ahead and do it that way. So I'm going to do, here's my x sub 1, my y sub 1, x sub 2, y sub 2. So I'm going to find my slope. I do 8 minus 5 over 2 minus negative 3. That gives me 3/5. So once I have my slope, now I'm just going to substitute in for my x and y and for my slope. So it's going to be y minus 5 equals m times x minus x sub 1. So watch how quickly I want you to be able to do this. So it's going to be y equals 3/5 x plus 9/5 plus 25/5. Let me pause for a minute there and show you what I did. This will save you a lot of time. Distribute, get your answer, and then think you've got to bring this over here, and you have to have a common denominator. So all that needs to happen at the same time. So our answer then is going to be y equals 3/5 x plus 34/5. Now, if I'm taking a test, a lot of people think, well, I can't check a line on my calculator. But you really can. If I go into y equals, and I type this in, how can I check it? Okay, second trace and do what? Okay, good. Do you know you really don't even have to do second trace? I can just do trace, and I can just put in 2, and it'll do it. Yep, same thing. Okay, great. So I can see that those 2 points are the correct points, just like they're supposed to be, so therefore, yep, we know that this would be the correct answer. Any questions over that? All right, so what do we do if we have a diagram? It says to find the average rate of change over the interval from 0 to 12. Well, here's when x is 0, and here's when x is 12. I'm trying to find what's the average rate of change here. Well, one thing I know is that my answer should be positive, right? This is saying when x sub 1 equals 0 to x sub 2 equals 12. This is not giving me a point, guys. This is giving me a range of the x's. So what do I have to do first? Find the y's, right? So Kyler, if I plug in 0 in, well, I can't even plug in. I just want to look at my graph. So what is it, Kyler? When x is 0, y is 0. And then what about at 12? What's that going to be? Natalie, when x is 12, what's y? And so now I have my 2 points, so now I can find just the slope, which is also called the average rate of change, which can also be called delta y over delta x. So now I can do 4 minus 0 over 12 minus 0, and that's going to give me 1/3. I can double check that by seeing, is this slope 1 over 3? Well, I rise 4 and I run 12, so 4 over 12 does reduce to 1/3. All right, any questions over average rates of change? Okay, it's pretty easy stuff, basically.